Thanks so
Okay,
much.
so
Appreciate it. Sorry that I was not able to share on my own here.
no worries.
Okay, great. So I'm talking about some work that's joint with Hilary Sigmund at Rutgers. This work is preliminary, so it hasn't been published anywhere. We just have a working paper that we've been out presenting and hope to have a submission out by the spring, maybe if not the winter. Go ahead, next slide. So as all of us know, right, lots of papers out there. This is just a figure from one good paper, right, showing that as the climate is changing, right, due to greenhouse gas emissions, the intensity, the duration, and the frequency of drought seem to be increasing as well, at least in some regions. And Texas is one of those regions, Texas in the Southwest. You'll note the columns here, right, they're kind of reference case on the left, 1 degree C, which we've already passed in terms of warming above pre-industrial levels. So somewhere between columns B and C now, and if you kind of look toward columns C and D, which is where we seem to be headed, 2 degrees C being the temperature threshold that the Paris Agreement nationally determined contributions are trying to avoid reaching, and lots of questions as to whether we'll be able to do that. But what you can see if you're kind of looking for Texas there is it's, you know, one of the regions that's lighting up as a place where we're likely to see more drought into the future. Next slide. So I love the recorded interview with Patrick, particularly because you'll note that most of the work that he was talking about focused on temperature, exclusively on temperature and the impacts of temperature on things like productivity and so on. And there is lots and lots of good work on that in the kind of what I would call the climate economy literature, or the kind of literature in economics on climate change impacts. Lots of good work showing temperature extremes reduce agricultural productivity, labor productivity. That's some of the work that Patrick was talking about, that they increase conflict and that temperature also can reduce overall economic output. That last study is more of that kind of top-down macro approach that Patrick was talking about. A lot of these same studies test for impacts of precipitation extremes concurrently, right? Controlling for temperature, is there an effect of precipitation? And they find either small or no significant impact and then conclude that temperature is really the major concern. But my co-author and I feel that there's a gap here, right? Because societies and economies do tend to adapt to variable rainfall in similar ways that we adapt to temperature, maybe even predating our adaptations to temperature extremes. You think about some of the functioning dams in the world that are the oldest ones are even, you know, thousands of years old. So things like dams and reservoirs and other, you know, kind of access to groundwater and so on are different ways, right, that different types of economic activity might have been able to adapt to variable rainfall. So we're asking a little bit of a different question. Rather than looking at just negative precipitation shocks, we're looking at whether drought shocks have such effects. And as we know, right, drought is a kind of richer, more complex phenomenon than just kind of temperature and precipitation alone. Next slide. So thinking about pathways here or mechanisms, how might we expect drought to affect economic activity? We've already talked about, right, from other speakers this morning, many such avenues. So our work is at the global scale, and I'll talk about our data and our approach in just a minute. In rural areas, there's lots of good papers in development economics and agricultural economics showing that drought reduces agricultural productivity, wages, employment. It affects migration and health, right? You tend to see a lot of out migration from regions, especially regions that are experiencing prolonged drought. And that's all excellent work. What is less well understood are kind of urban, regional economic impacts of drought beyond those rural and primarily agricultural impacts. These are less well studied. And our goal is to try to pick up the signal of some of the stuff that Patrick was talking about. Like if we were to see kind of less worker productivity, if we were to see less, even the kind of electricity, you know, demand, you know, work that was on the agenda earlier. And there is some work on this, right? So there's a nice paper looking at dry shocks between 2005 and 2014 in 78 Latin American cities showing negative effects on employment, wages, other labor market outcomes. We see in some droughts in Africa, this one studied in Lusaka, Zambia, looking at water outages and showing things like increased disease incidence, so human health impacts, reduced banking transactions. Again, there's a sector you might not expect to be affected where they find impacts, and things like increased time spent on chores by girls. We do see increased rural to urban migration. So there, if we're looking for urban impacts of drought, you might actually see some positive effects, right, on urban economies. If people are moving from rural areas into urban areas, right, that could kind of go either way. There's a lot of ways of thinking about that. And then, as Patrick noted earlier about kind of evidence in industrialized countries, there's also evidence in other settings that drought can increase local violence and social conflict. And that seems to be true, especially in highly populated areas. Next slide, please. So as I mentioned, there are a lot of mediators out there, ways in which, right, things, infrastructure, natural infrastructure, built infrastructure that can mediate the impacts of drought on these kinds of mechanisms. Dams and reservoirs are one important set of those kinds of tools. There's good work on this. You know, obviously the purpose of those kinds of infrastructure investments are to smooth variation in water supply, and that can reduce drought's economic impact. On the other hand, there's also good work in economics showing that when dams are constructed, there are sort of some costs that are imposed both upstream and downstream. And so those can be significant. In fact, in the study that I'm studying there by Duflo and Pandey show that in India, they may be so significant that a lot of those investments would have net negative welfare impacts if we were to kind of put them up to a benefit cost analysis. And then my co-author on this paper and I have a prior paper published work showing that in international basins, we're actually more likely to see dam construction in international basins, largely because countries can kind of pass some of those downstream costs across international borders. So dams are kind of potentially a mixed bag, and we're gonna look at that in our study. And then also access to groundwater resources can reduce drought's economic impact. We don't know of studies that establish such a link empirically, but on the other hand, water users can also adapt to groundwater access by increasing the water intensity of production. So this paper I'm citing by Hornbeck and Keskin in 2014 looks at what happens in the kind of Great Plains in the United States when farmers get access with electric pumps, right, in the 30s, 40s, and beyond to the Ogallala aquifer. And they show that over a long period of time, right, in the beginning, this kind of reduces drought sensitivity. But then as we adapt and we plant more thirstier crops and so on and sort of shift to this new normal, we can get this effect where the groundwater is no longer, really kind of buffering those drought impacts. Next slide, please. So what are we doing in our study? We're trying to estimate the global economic effect of drought on economic activity. For the measure of economic activity, that's our outcome variable. We're proxying that with the intensity of nighttime lights from space. So this is a reasonably common approach now in the economics literature. There are a lot of appealing aspects to those data. One is that they're available at a very fine spatial scale. And if you're interested in drought impacts, GDP is often available at the national scale, but drought doesn't necessarily happen as a national phenomenon, depending on the size of the country and so on. And so we have that nice fine spatial scale, and it's also available everywhere, right, in a systematic fashion, very unlike GDP estimates, right, which are kind of collected by lots of different agencies in different countries, and at the subnational level, it gets even more complicated. So that's our outcome variable. At the very end of the talk, I'll talk about how you go from kind of lights impacts, right, if drought dims lights, what does that mean for GDP? And there are sort of elasticities out there in the literature that help us understand how to do that. We're going to measure drought at also a fine spatial scale. We'll use two different drought indices throughout the paper. One is the Drought Severity Index, right, available from the University of Montana. The other is the self-calibrating Palmer Drought Severity Index. And you'll see that the results differ in some ways, especially at the tails when we look at those two different indices. And then we're also going to examine this capacity of constructed infrastructure in the form of large dams and the reservoirs that they impound, and natural infrastructure in the form of groundwater aquifer access, sort of differing quality to mediate drought's effects. Our contributions are this global scale of the analysis, the fact that we're focusing, I say, urban-ish effects, and that's largely because it's still a little unclear in the literature how much economic activity in rural areas the lights data actually pick up. For the most part, we're going to be kind of capturing activity that's happening in very, very well-lit areas. So we're not talking about sort of a village with a single light bulb in each home, but more like lights that are in large parking lots in suburban and exurban areas, city lights, kind of big agglomerations of buildings and so on. Okay, next slide, please. We can mostly skip over that, but let me just sort of talk briefly about what it is that we're doing. So again, our outcome variable here, that's the variable on the left-hand side at the equal sign here. That's my lights variable. Okay, so this is going to be available at the half-kilometer grid cell level. So I'm looking at kind of what's going on at that scale in each year for each grid cell. And on the right-hand side, that's going to be a function of a set of bins, and I'll talk about the bins. We'll sort of see those in the data that are defined in the literature for each of these two different drought indices, right? So depending on whether your kind of average drought index was kind of in what bin, extreme drought, all the way down to kind of incipient or mild drought during that year, that's going to be the effects, right? Those kind of gamma Ks are going to give us the effects of drought. And then we have a set of hot, very flexible kind of comprehensive temperature controls, largely because of kind of speaking to this economics literature that's strongly focused on the effects of temperature. So you can think of, even though, right, temperature is in our drought indices, we're going to think about those drought effects as kind of controlling for temperature, kind of trying to take out that effect that is already there and well estimated in the literature. And then the other variables there, is basically a grid cell fixed effect. So we're going to be looking at everything, kind of effects within a cell of a drought relative to the norm for that cell, right? So anything that's non-time varying about that cell is controlled for, and then a continent by year fixed effect as well. Next slide, and you can actually skip the next one and go to the next one. Yeah. So a little bit about these lights data. So these are the nighttime lights data that are measured by the Defense Meteorological Satellite Program Operational Line Scan System, or DMSP-OLS. It's available annually from 92 to 2013. There are some newer kind of lights data that are available after that, but our period that we're looking at is 2000 to 2011. So we're going to be using these older kind of Defense Department light satellite data. Each half-degree grid cell is about 2,500 square kilometers, and the area of that actually varies, but with latitude, that's why I have that approximately 2,500 square kilometers. The spatial precision is very fine relative to how we would typically measure something like GDP, right, or have available through traditional national accounts or surveys. And then again, because we have those grid cell fixed effects in the model, the drought effects are going to be identified from variation in lights over time within a cell, right? So, kind of controlling for each cell's norm. Next slide, please. Just to think about our main independent variables, those are the drought indices. Again, as I mentioned, we're using two. We're using the MODIS Terrestrial Drought Severity Index, or DSI. There, it's going to combine satellite observations of evapotranspiration and vegetation greenness. It's available annually, again, at this nice fine spatial scale. We're going to aggregate to the same scale that the satellite data on nighttime lights are available to at. It's a continuous index. It's normalized with a mean 0 and standard deviation of 1. And then we're also going to use, kind of as a robustness check or a comparison, the Palmer Drought Severity Index, the self-calibrating version of that. That's going to be, so think about the remotely sensed product as the DSI, the kind of ground monitor based product is the SCPDSI. That's going to combine data on temperature, precipitation, soil moisture, and so on. It's a continuous index ranging mostly from -4 to +4. And again, we're going to be averaging at that same level, spatial level, that the satellite data on nighttime lights is available at. Given that each of these two indices have kind of appealing characteristics and drawbacks for the study that we're doing, we're going to use both of them in the analysis, and you can see how they differ. Next slide, please. This is just to show you some preliminary results. So here we're using both indices kind of across their full range of values. And see, these are the bins that are defined in the literature with, kind of within ranges of each of the two indices. So the blue results here are using the Palmer Drought Severity Index product. And then the red results are using that MODIS, the remotely sensed drought index. And what you see here is a few different things. So, right, 0 or kind of no effect is marked with a red vertical line in the middle. And then each dot is a coefficient estimate, right, kind of depending on the index and depending on the bin of drought or kind of wetness severity. And then the bar there is the 95% confidence interval for each of those coefficient estimates. And what you see kind of is, we're to the left of 0 or in the range of dimming lights, reducing economic activity when we have those average annual conditions kind of at the grid cell level that are in the extremely dry, severely dry, moderately, mildly dry levels. And it's surprising to us that there are significant and negative effects, even for fairly mild drought conditions, right? Looking at that mildly dry to moderately dry, that range in there. The one exception, and it's potentially important, is that when we use the Palmer Drought Severity Index measure, we get that noisy estimate of the negative effect in the extremely dry category. Here you have to think, right, there's actually a fairly small number of observations in that category, even globally in any given year, largely because, right, it's that, we're looking at extremes. This is kind of a classic problem in climate economics where, often you get a fairly small number of observations in some bins. And so that's just something to keep in mind, right, that effect for the one of the two indices is not significant, statistically significant in the extremely dry bin. The other thing you'll see is that, right, if anything, unusually wet conditions, again, some of those estimates are noisy. We don't have as many that are significant right on that end of the scale. But if anything, those seem to help things out, right? You sort of get more lights under those conditions, more economic activity under those conditions. The same is clearly not true on the drought end of the scale. Next slide, please. Another thing we look at is kind of when those effects tend to take place. And so what you see in the first set of estimates there where it says moderate or worse drought. So here what we're doing is we're compressing those drought bins. We're kind of taking out the wet side, compressing the drought bins so that we're going to just call something a drought if the annual average conditions are moderate or worse, right? So taking out the incipient and mild drought conditions and just say, hey, there's a drought in this year in this grid cell, right? If it hits into this range of moderate or worse conditions. And so very similar to the estimates, we had that kind of the estimates in the prior graph are about a 1% dimming, maybe higher for some of the more extreme conditions, but about 1% dimming of lights for a moderate or worse drought. And that's what we're kind of reproducing in the first set of estimates there up at the top of this graph. And then looking, okay, what if you had those conditions 1 year prior to the year in which we observe, right, the grid cell? And that's the second, where it says 1 year ago, that's the second set of estimates, kind of right in here. Again, using the two different indices, the Palmer Drought Severity Index in red, and then the DSI, the remotely sensed product in blue. What if you had those moderate or worse drought conditions 2 years ago? What if you had them 3 years ago, 4 years ago? And what we find is a fairly surprising, very similar pattern, again, different in magnitude, but not that different, using the two different indices. And a fairly interesting pattern that, yes, the drought in the current year suppresses lights, it sort of dims lights, but it also, the droughts seem to have these lagged effects, right? That even if you had a drought 1 year ago, that affects economic activity today. Same with 2 and 3 years ago, even 4 years ago, maybe we're getting closer to zero at 5 years, but we do seem to see this kind of lagged effects of at least 3 to 4 years of drought conditions. Next slide, please. So again, thinking about these extensions of testing for kind of mediating influences of groundwater and dams, I just want to explain very briefly what we're doing data-wise here. We're using some data from the World Bank, and we've developed kind of binary indicators for moderate or worse drought that we're going to use that same thing that I just showed you in the lag drought the slide, right, for thinking about the impacts. And then we're going to interact those indices with a set of variables indicating whether the maximum share of the kind of aquifer typology underlying each cell falls into the following 4 categories: major alluvial aquifers, local shallow aquifers, complex aquifers, and karstic aquifers. Karstic is going to be the emitted typology when we actually run the regressions. And then we're also going to interact the drought variable with a measure of the long-term average recharge in the grid cell in cubic kilometers per year. Next slide, please. And here I don't have a simple graph to show you, so I'll just talk very briefly through some regression results. So here's just kind of repeating with no groundwater stuff in the regression, kind of that binary effect of a moderate or worse drought in the current year, giving us about a 1% dimming of lights. And then here's in these 2 columns where we add these interactions with kind of access to underlying groundwater. And what we see is when we interact, right, that moderate or worse drought with the presence of major alluvial aquifer resources, we see that that is about kind of approximately going to ameliorate, right, the effects of the drought. So it's about the same magnitude, right, as the impact of the drought itself, and it's positive rather than being negative, although only weakly significant. And then here in the 3rd column, we add, right, both the aquifer types and also the recharge. This is the average recharge number. And here again, we see that similar effect. Hey, access to the, right, we get a stronger effect of drought, and access to the groundwater resources seems to help. And the richer are the groundwater resources, right? So the greater is the recharge, the greater is the kind of mitigation of the drought effects on lights. Next slide. I'll just mention we do something similar for dams. I don't have time to talk about the dams data very much. We're just looking at the impact of large dams in the local watershed, the kind of sub-basin that the grid cell is located in. This is just repeating those kind of moderate or severe extreme drought impacts, getting, again, very consistently from model to model, about a 1% dimming of lights. And then here is the presence of a dam in this 2nd row in the local watershed. And in some of these models, we're getting, again, similar to the groundwater story, kind of an approximate mitigation of the drought effect of having access to those water resources, right, and infrastructure in the local basin. Not surprisingly, right, that if your source of electricity is hydroelectricity, right, you get the opposite effect, right? So if you have a hydro dam in your local basin, you actually might get an even greater dimming of lights than what you would see, but you still get that ameliorating effect of other kinds of dams, right, in those basins. Next slide. So just a couple of preliminary conclusions. Again, it's early. What we see is moderate to worse drought seems to reduce economic activity on a global scale, reducing lights by about 1% on average. So I'm going to do a back of the envelope calculation here, which is never a good idea, but here we go. So if we looked at average global GDP between 2000 and 2011, this was the period of our study, that was about $65.4 trillion in 2022 dollars. And that conversion factor from what is happening with the lights to what happens with GDP is about 3/4, about 0.76. So a ballpark estimate of the kind of economic impacts of drought in these regions between 2000 and 2011 would be about $500 billion in annual GDP loss over the period, which is a pretty big number. Again, we see significant but smaller effects for mild and incipient drought, and because we're just looking at those effects of moderate or severe drought in those numbers in that first bullet, those aren't included there. Because we're looking at nighttime lights as our measure of economic activity, it makes it likely that these impacts are primarily kind of urban, suburban, exurban areas. Clearly, some towns exist to support agricultural activity, right, in especially small towns in developing countries or in rural parts of industrialized countries. To the extent that we're picking up lights there, we could get some kind of macro effects of what's happening in the agricultural sector. But mostly what we're talking about here would be kind of urban, suburban, exurban effects. So picking up the kinds of effects that Patrick would have been talking about in his talk. And then we find some ameliorating effect of both access to kind of more and better groundwater resources, and also the access to dams in the local watershed. And that's all I have for today. Happy to take questions.
Thank you. If there is any question, please raise your hand or write it in the Q&A. Okay, from Andrew Dessler, what's the physical connection between drought and night lights?
Yeah, it's a great question. So it's not so much, so there are some clear physical connections, like that hydro dam, right, result that I showed just toward the end, right? So some places may literally rely on water, right, for generating electricity, and electricity is what generates the lights. And so you can have direct connections like that. But for the most part in the paper, what we're trying to do is use the lights as a proxy for economic activity very generally. And the challenge here, right, is if you want to pick up those effects, right, often what you see in terms of drought impacts calculated would be, adding up agricultural losses, crop losses, livestock losses, and so on. To a large extent, those kinds of losses would be added to whatever we see in terms of suppressing economic activity in cities and in suburban and exurban areas as well. And so that's what we're picking up. And the question is kind of what are the mechanisms? Well, they would be things like reduced worker productivity, which are well demonstrated, right? Reduced, again, we've seen these very diverse impacts in the literature, reduced banking transactions and so on. But at the global scale, right, we don't have sort of data on each of these different types of activities where we're putting those into the model to understand exactly what is the contributing portion, right, of each of those kinds of effects.
Any other question for Sheila? Well, thank you, Sheila. Maybe we can